On this particular video, I will show you how to do your load separation if your generator is a 3-phase generator but your inverter is a single-phase inverter. So we do have cases like that more often, and because your generator is 3-phase, it is expected that the wiring system of the building would also be 3-phase, which means this is the type of DB you are going to be seeing at that particular site. And secondly, the Nepa, which is the grid, also would as well be 3-phase. And this is the type of changeover you will find there in most sites. This is a knife switch changeover, the bigger type. You can see the metal box, and it is a 3-phase changeover. It even has neutral as well, so it switches 4 poles together. While in some small electrical wirings that is still 3-phase as well, you will see this type of changeover, the normal plastic ones or the ceramic ones. You can see the 3 poles. Some also comes with 4 poles. One will be neutral, you understand. But whichever way, let's get down to the separation of the load when you're using a single-phase inverter system for 3-phase house wiring. Now, as usual, power will come to the distribution bus from your changeover. We'll call it CO, the output of your changeover. And unlike the initial one we demonstrated, this one will now be separate 3 lines that will come to the distribution box from the changeover, which is red, yellow, and blue phase of the 2 power sources. That's the Nepa and the generator. Now, if we are putting an inverter or installing an inverter on this particular site, and the inverter is a single-phase inverter, it simply means that inverter cannot power every single thing in this site, right? Because if the inverter is to power everything, then we'll have to rewire this wiring and make it a single-phase unit, which is also not advisable for the generator part. If your generator is 3-phase and that generator is, for example, 100 kilowatts, it has to divide into 3, which is around 33 kilowatts per phase. And for that generator to function well, the load on each of the phase needs to be balanced. So it is not even advisable to run this into a single phase unit. So you still maintain the 3-phase. However, what you now need to do is to use one of the phase for the inverter, which means one of the phase of the generator is what will go to the inverter. Remember, our inverter is a single phase inverter. We are going to utilize one of the phase. And you also need to pay attention that when you are now using one of the phases to power the inverter, that there are going to be a disbalance on the load balancing that was done on this entire electrical wiring, because that particular line is not just only powering that load through the inverter, it will also charge the battery the inverter will come with, you understand? So you make sure you still rebalance the entire electrical system by putting more loads on the other 2 phases, so that everything will still equalize at the end of the day. So what we need to do is very simple. Let's say our inverter is over here. This is IMV, right? So we are using this particular phase. So instead of the phase to go to the DB, it goes straight to the inverter, right? The neutral as well will go to the inverter to charge the inverter. Then the output of the inverter will now go and replace that particular line. So we'll call this line the red line. So anything on this red line will now be going through the inverter. The neutral of the inverter as well would as well go to the neutral bar. And of course, the neutral here is as well going to the neutral bar. So our common neutral connection. For people who have issue with common neutral connection, we'll make a video explaining what exactly a common neutral means and how an inverter even operates, because some people don't even understand that most inverters, the neutral are already connected. The neutral are together inside with the design of an inverter. I would make a video and break every single thing down about the neutral of an inverter, but let's focus on what we came to discuss today. This is simply what the connection will be like. This particular phase that we call the red phase now, so everything on this breaker, the inverter will now power it. The line from the generator, that is from the changeover, either the grid or the generator, one of the phase goes to charge the inverter, so it goes through the inverter back to this place. If this is not available, the inverter will power everything on this particular line. So it is as simple as that. On the next video, I will show you what to do if your generator and grid are 3-phase, just like we have here, but you also have a 3-phase load on your DB, how you will do the separation when your inverter is still a single-phase inverter.